Rust has a powerful module system that they make it fairly straightforward to use. It's hierarchical in such a way that you can have a lot of hierarchicalness. You can have nested modules, as many as you want. You probably shouldn't do it. It's probably something you shouldn't do, but you can do it. In Rust, a module is a collection of items. They're functions, structs, traits, implementation, and even other modules. So you can have all these. You can have a module, a whole bunch of functions, and then a module inside of that, and then more functions inside of that. You could go crazy if you really wanted to. Let's take a look at what that looks like really quick. All right, here's a module. We've got a module. MOD is the keyword that you use to define a module, and then you just name the module, and then you specify a block after that. And then everything that you normally would write in Rust, like a function or a struct or a type or any of those things, they just go nested into the module just like that. So you define a function here. And there's scoping in terms of visibility. Now this is critical. Visibility is like, can you access the function or any of the data or the module itself outside of the scope? So if you're sort of bringing in a module so you can use its functions, would you be able to use this private function here? No! No, right? Why would you be able to use this private function? And it's private because it hasn't been labeled with a pub modifier. By default, in Rust, all things inside of modules are private from that scope perspective. So you can add pub to it to make it public, so it then is accessible outside of the module. So you can say mymod and then the function. And this is how you call it. See we here? mymod : private function. That's how you access functions inside of a module. Although this right here, you're going to get a nice little fun error if you attempt this because it is a private function, right? It's inaccessible. And it's done that way on purpose. You usually have utility functions internally within your module that you'll need to call just for organization purposes, and they don't need to be accessible from an end user because they have a public interface that is much more meaningful and powerful to them. They don't need these internal functions. So that's why you can do it like this. If you have a module, can you stick another module inside of that module? Can you put another module inside that module? Actually, you might be able to. You at least can you do it? So we've got one module here, for example. We're taking a look at the screen. We've got a regular module, and then we've got another module nested inside that module. But can we put a third module? And how deep is there a limit? Let's see how far we can go. At least you would never want. This is something you never want to do. There's just such a rare case where you'd want to structure something like this. It's just overwhelming. All right, I've created a bunch of nested modules. Probably we never want to do this. Let's see if it actually works. We're going to try it out here. Nested and nested 3. Is that going to work? I'm pretty sure it'll work. I'm pretty sure let's see if we get any compile. We didn't get any compile errors. We got our print statement super nesting. So if you really wanted to, you could have a lot of modules embedded inside of modules. Modules inside modules. I bet you could there's got to be some sort of limit. After looking around the internet for a little bit, it looks like there's no limit. You can go as far as you want, which is ridiculous. You can have as nested modules as you want. You essentially will hit your own practical limit because you don't want like this giant string of modules that you have to traverse. So it gets unwieldy at that point. You wouldn't even want to bother. So there you go. If you really want to, you probably don't though. But maybe in a Rust struct, do each of the fields have their own visibility in terms of like public, private, right? If you have a struct that's being accessed outside in another module, would you be able to access that struct or any of its fields? You would think that if a struct is public itself, all of its fields are accessible, right? Isn't that, you would assume this. But it's not the case. In this case, everything, the struct itself and all of its fields must have a defined public, otherwise you cannot access the field. I get some power to this. It makes sense. There is some capability here where you would want only certain elements of that struct itself to be accessible if you're using it in a user interface for your programming. If you're making this code for other developers, you might not want them to access some of the more internals. You just want them to access just the important parts. Or, I figured you could just have a function that does some of the setting and getting of the data that's needed. However, if you are passing around structs, you can make certain elements, certain of these fields can be private. For example, this a public struct with one field in it that's private, which means you can't access anything. You cannot access anything in this struct. It is completely inaccessible. So the examples they have here are pretty nice. They have a struct open box, and they have a struct closed box. In the open box, we can access our contents. But in the closed box, there's no accessing anything. You cannot access any of it. Oh, wow. It's so closed that even if you try to instantiate a struct that has a private field in it, it'll fail. That is, you must have an implementation here that allows the code itself, you need to have access to the scope in order to even instantiate this struct. That's interesting. Okay, that's pretty restrictive. So with the open box, right, where we have a public field contents, you can easily here just create your own instance straight up, no problems. However, if you attempt this with the closed box where you have a non-public field, it's gonna fail. This is not possible. I mean, are we gonna get an error? Let's find out if we get an error. It is intention. Okay, this line is not, you cannot do it. So the pattern you'd want to use in this case is you have to create a function that creates the struct for you that has access to the scope of the field that's part of the struct. This is ridiculous. But it is nice because it gives you the ability to sort of fully collect the user experience, right? You're defining an interface. And this interface is what other developers will be using when they interact with your code. And it's a little nicer than having to deal with the understanding about what's inside of your module, right? You'd rather provide a module that has a whole bunch of code, but you only need to use one or two of the functions within your module for it to be super useful. That would be a good module. A module that's really powerful, it's robust, but the end user, the developer who's going to be using your module, only has to use one or two of the functions that you've built into it. That is a fantastic module.